That is, of course, 2 times 144. 144 has a square root. It's 12, so that's negative 72 root 2. 30 doesn't get any simpler, so that is the same. Who's doing number 3? $14. It is 14. 14 root 10. That's how we say it. That's okay. Ten root 147. Pardon? 70 root 3. 6 root 343. Yep. Uh-oh. Now we're in trouble. Minus 10 root 5. Yep. Down here. Now, one sec, actually. On these, people may need to see both steps, yeah? So this first one was 4 root 10 minus 5 root 20. And then you break down root 20, 4 times 5, out comes the 2. Right? So let's come down to here. Root 45 plus 5 root 15, and that's 9 times 5. So that's 3 root 5 plus 5 root 15, because 15 doesn't break down. Can I just go with the answers now? Hit me. Who did number 8?
Root 10 plus 5.
Yep. Root 10 plus 5. What do you got to do with number 9? Can you add those up right now? No, so what do you got to do? Simplify, simplify, simplify. 4 times 2, so that's 4 root 2. 9 times 7, so that's 12 root 7. 9 times 2, so that's minus 6 root 2. Now, can any of that go together? The root 2's can go together. So that's 12 root 7 minus 2 root 2. Could I also write negative 2 root 2 plus 12 root 7? Is that allowed? I'll take it by your silence that you know that it is. Now, you could simplify here now because these are the same, or you could simplify everything and then work it through. Doesn't really matter which way you do it. I'm going to simplify this guy now, negative 8 root 6. And these two, I'm going to simplify 4 minus 3 is 1, so it's just root 63, which is 9 times 7, so it's plus 3 root 7. And that's that answer. 45, 9 times 5, so it's 3 root 5, plus 96 is 16 times 6, so that's 8 root 6 minus root 6, 3 root 5 plus 7 root 6. 9 times 7 is negative 6 root 7 minus 2 root 3. 7 times 4 is plus 8 root 7. Negative 6 plus 8 is 2. 2 root 7 minus 2 root 3. Again, order doesn't matter. And finally, the last one. That was 16 times 3. which is 12 root 3 minus root 5. 9 times 3 plus 12 root 3. 24 root 3 minus root 5. Now, of course, this would have been the perfect thing to do a homework check on, but because it was your first day back, and I trusted that I would get the result that I would be worried about getting, I did not do that. You'll be quizzing on this in a moment, well, a few moments, and that quiz is as good as a homework check. What? Did I make a mistake? It's possible.
On 11.
11.
I get that 45 is 9 times 5.
Yeah.
So
I forgot to bring the 3 out, didn't I?
yeah.
So that's 9 root 5.
Yeah.
So that's 9 root 5. Once again, I remind you all, there is no benefit, as you can plainly see, to rushing through this. Because it is very easy to make a simple mistake. Yeah? Yesterday it happened like 6 times. Today it happened once so far. Eventually my brain will also turn back on. Hopefully it will be faster. Yeah, yeah? Yeah, yeah, yeah. Okay, now, I'm going to take about 25 minutes to run through this, which won't take very long. Then I'll leave you with some work and I'll start your quiz. Now, I have made, what's the word I'm looking for? I have done something that I do not normally do. When I am showing you guys stuff in math, I don't usually give it nicknames or tell you little stories about how the princess is trying to get the exponents out of the castle of brackets. I don't do that. But sometimes, very rarely, I do. And I've done it here. This is not really a word, okay, in math. I've used it as a title here so you can see what I am talking about. It is when I have a base with a fraction as an exponent. The proper math terminology for this is rational exponents. But I don't like saying that on the first day at the very beginning because rational applies to a whole bunch of numbers that aren't fractions, right? Or they are fractions, but we don't like to write them as fractions. So I've called it fractional exponents, but yeah.
Isn't how that would work is that as long as the numerator is a 1, it's basically the square root.
Yeah, we're getting to that. Okay? Don't give me away.
Sorry.
That's all right. So, use your calculator to do this. Now, Aiden's just given us away, but on your calculator, this is 9, then your exponent button, then use brackets. There's a reason for it. Bracket 1 divided by 2, because that's 1 divided by 2. Then hit equals and tell me what you get. Aiden's given us away. That's okay. It's all right. What do you get? 3. Now do the same thing here. 27, exponent button, bracket 1 divided by 3. Tell me what you get. 3. Now do the same thing here. 625, exponent button, bracket 1 divided by 4. And what do you get? 5. Now, all of you, if you had your squares and cubes memorized, you should already see a pattern here. Aiden's already said what it is. 9 to the 1/2 got me 3. Have we seen any other relationship between 9 and 3 in this unit? What is the relation? What is it, Evan? 3 cubed for 9?
No.
You're right, squared. You just said the wrong one. So we all know that 3 squared equals 9, which automatically means that the square root of 9 equals 3, yes? Everybody with me? What else do we know? We know that 3 cubed is 27, which automatically means the cubed root of 27 is 3, right? And if we used our calculator, we would find that 5 to the 4th is 625, which automatically means that the 4th root of 625 is 5. Is everybody cool with that relationship? Right? Easy, right? You can see it right there. But remember back a few, weeks ago now, we talked about that piece of logic where if A equals B and B equals C, then what do you know about A and C? That they equal each other, right? So, if the square root of 9 equals 3, and 9 to the 1/2 equals 3, then what do we know about 9 to the 1/2 and the square root of 9, which is going to show up in a second? What do we know about those two? He waited patiently. 9 to the 1/2 equals 3. A equals B. They both equal the same thing. So what do we know about these two? They equal each other, right? Now, look closely. What do you see right there in the index? A 2. What do you see right there in the rational exponent? A 2. What should you see right there with the 9? But we don't write it. What's the exponent always that we don't write? 1. What do you see there? 1. If it happens in math once, how often does it happen? Every time. So, 27 to the 1/3 must equal the cube root of 27. Please notice the denominator becomes the index, the numerator becomes the power. Does everybody see that?
So when you just have like 27 with 2 over 3, you would first raise 27 to the 2 and then root it by the 3.
Yes.
Awesome.
So, let's put this into perspective. Now, I think your guys' page is not screwed up like mine. Your B is not right there. So, I just want to erase that B so it's out of our way. So, let's have a look at this situation here. I have, what's the base in A? 0.04. Now, what was the base here? 3. What was the base here? 9. What was the base here? 27. What was the base here? 625. Where does the base go every time? Inside the root. It becomes the radicand. I've used that word a lot. I'm going to write it down again because I need to be able to say it and have you know what I mean. That is the radicand. It's the thing under the root sign. Everybody good? Where does the denominator go? It becomes the index. And where did the numerator end up? It becomes the power. Everybody cool? So first I need the square root of 0.04. What is it? Most of you are going to use your calculator for that, but you shouldn't need to. What's the square root of 4? 2.
So it's
0.2. 0.2 cubed, right? What is 0.2 cubed? What's 2 times 2 times 2? 8. And every time you multiply decimals, you need to add a decimal place, yes? So how many decimal places do I need? 3. So this equals 0.002. Sorry, 008. Everybody with me? Could have done it with the calculator, but you didn't need to. Everybody good? All right. What's different? Now, what is your B? Your B is... Oh, yours did photocopy badly, too. Okay. So your B was 27 to the what? 4 over 3, right? That's your B. Okay. Tell me, where does the denominator go? In the index. So I need a cube root. Where does the base go? Where does the base go? Pardon me? No. The base. 27's the base. Where does it go? To the radicand. And then all of that is to what power? 4. What is the cubed root of 27? 3 to the 4th power. What's 3 times 3? And then 3 times 3. And what's 9 times 9? 81. Does everybody see how rational exponents work? Okay. What's happening in C? This is another example of not being able to forget all of our previous math. Do I have 2 exponents here? Are they going over a bracket? So what math do I do? Multiply. What is 2 times 1/3?
Isn't that 2/3?
Yeah. It's not a trick question. This is 8 to the 2/3. Why? Because we had to do 2 times 1/3. Everybody cool? Now again, what happens to the denominator? Index. What happens to the base? Becomes the radicand. And then the whole thing is what? Squared. What's the cubed root of 8? 2 squared. What's 2 squared? 4. And you're done. Does everybody see how it works? It's pretty easy once you see this up here, it's pretty easy, right? Okay. Let's look at D, and let's try to figure D out completely by ourselves without using a calculator. We can see that it's a base and an exponent, yes? Okay. So, what happens to the denominator? Index. And everything's going to be to the 1st power. So do we care? No, because we don't need to write the 1st power. But what goes under here? 0.49. Now, this causes kids some problems. Because I can see right now a bunch of people are already reaching for their calculator. But there's no need to. Because 0.49 is what? No, just 0.49. What is it? 49 over what? 100. So if I have to square root everything under there, what's the square root of 49? 7. What's the square root of 100? 10. So this answer is 7 over 10. which is, of course, 0.7. Everybody with me? Now, here is something that you may wish to commit to memory. You may wish to memorize this. I've said memorize other things. You haven't, but I'm going to continue to try. If you have 2 decimal places, the square root has 1 decimal place. If you had 4 decimal places, what would the square root have? 3? 2.07. What if I had 6 decimal places? What would the square root have? 3.007. Right? Why? What happens when you multiply decimals? You need all those decimal points, don't you? Right? 1.5 times 2 is 330, and I needed 1 decimal place, correct? That's why this works. What if I had 5 decimal places? Could I get a square root? No, why? Two, 1, 4, 2, 6, 3. Why can't I get a square root if there's 5 decimal places? Because you can't cut it in half, can you? Everybody with me? All right, what's different about E? The exponent's a decimal, isn't it? But what do we know about all decimals? Does that decimal end? So is it a fraction? You got a 50-50 shot, man. Yeah. What fraction is 1.5? 3 over 2. 16 to the 3 over 2. Do you know how to do that now? What do you do with the 2? Square root of 16 to the 3rd. What is the square root of 16? 4 to the 3rd, which is 64. You guys do the last one. If you can't figure out what 0.75 is as a fraction, so what is it? 81 to what power? Yeah. 81 to what power? Still waiting. Three over 4. Awesome. Now what?
81 goes to right hand, and 4 goes out for the next.
So we need the 4th root of 81 cubed. We already know what the 4th root of 81 is because we just did it. Right? We did it right there when we did 3 to the 4th and got 81. So the 4th root of 81 is 3. But maybe you don't remember 2 minutes ago when we did that. So then you would break it down. 9 times 9, 3 times 3, 3 times 3. There's my group of 4. So the fourth root of 81 is 3 cubed, which is what? 27. And that's the easy ones. Those are the ones we can actually work out. Look at the next one and tell me why I say you have to use a calculator. I mean, if we follow the pattern, that's the fifth root of 8 squared, correct? Does 8 have a fifth root? No, of course not. What's the largest root we can get out of 8? A cube root, right? 2 times 2 times 2. We can't get a fifth root of 8. So sometimes we have to use our calculator, especially when we're using these for science equations, right? So to do this on our calculator, first thing we say to ourselves, self, there isn't a fifth root of 8, so this is the calculator situation. But we already know how to do that from the very first thing we did, right? The base is 8, then we use the exponent button, and then how do I do that on my calculator?
You can either put it in brackets for 2 divided by 5, or you can use an actual fraction button to make it 2.
Yeah, you can either do 2 divided by 5 if you don't have a fraction button on your calculator. But if you do have a fraction button on your calculator, which looks like this usually, ABC, you can make a fraction. And you would do that by doing 2, then the ABC button, and then 5. And then you get a crazy answer, right? You get a whole bunch of decimals. What do you get?
2.2973967.
Is that rational? No. So what do we usually round it off to? How many decimal places am I usually happy with?
To the 10th, so 2.3.
2.3 I would be perfectly happy with. Is everybody with me? You guys do the next one. Again, you may use your fraction button or you may have to do 2 divided by 5. What do you get? I'm sorry, what was that, Aiden?
0.334.
Yep. So,
The point is, it would be like 0.3 or 0.3.
0.3346664, right? Blah, blah, blah. I'd be perfectly happy with 0.3. Is everybody good? If you can simplify it, we simplify it. If you can't, we have to go to our calculators. Everybody good? Okay, turn the page over. In this question, I've given you a formula. There it is. How do I apply that formula? B equals 0.01 m to the 2/3 with this situation. Is that the B or the M? Is that the B or the M? B is the brain mass, M is the mass of the animal. So where does that 27 go? Mass of the animal. 0.0127 to the 2/3. Now, is this a calculator situation or can we simplify this one? What should I do first? The exponent or this 0.1? The exponent, because of bed mass, right? Do we know how to deal? Can that be done without a calculator? Is that simplifiable? Sure it is. Because what is that? The cube root of what? 27 to what power? 2. What is the cube root of 27? Say it loud and proud, Wong. 3. What's 3 squared? 3 squared is not 6. 9. So the brain of a dog, we can estimate it to be 0.01 times 9. Right? So 0.09 kilograms. Everybody with me? We can do that without a calculator. Is it possible to do B without a calculator? Where does the 200 go? So what do I know about this part? That's the cube root of what? Cube root of what? 200 squared. Does 200 have a cube root? 5 is 125, 6 is 216. Does 200 have a cube root? No. So this has to be a calculator. What about 60? I know I'm going to need the cube root of 60 squared. Does 60 have a cube root? 2 or 3 is 27, 4 is 64. So does 60? No. So 60 is another calculator one, which I'm going to ask you to do. And then this page is your homework, but I'm about to give you your quiz. The answers are on the next page. So, desk's clear, calculator out if you need it. I'm going to give you your quiz. The first 4 questions, which are on exponents, are multiple choice. Then the last 2, 4, 6, 8, 9 are open-ended. If you finish your quiz, what do? You keep it and then you work on your homework. We are going to mark this quiz at 9:23-ish. Yeah. You might have. It was left here yesterday.
Yeah.
Remember, quizzes are nothing to worry about. They are just there to show you what you need to study. Two, 4, 6. 6. 2, 4, 6, 8. Now, I will give you until 9:22, and then if you're not done, it doesn't matter, because we're going to mark it. You can write the right answers down. No, I've got rolls of paper towel over there. It's the best I can offer you. Go, diddly o. Please remember, even though they do not count for marks, quizzes should not be a team effort, because they are designed for you to know what you need to study more on. Easy come, easy go.
There you go. Vegas is good.
It was kind of cold. Rain for a day too. Yeah. Almost too cold to use the pool.
Really?
Yeah. Most people were out there wrapped in towels like blankets. Yeah, it's kind of weird. Yeah. What are you gonna do? We hiked Red Rock.
Nice.
That
You
was
guys
really
go to the Grand Canyon one now?
No, we didn't do that. It's too far. But we went to the Hoover Dam. But ironically, there was no dam tours because there was no power for the elevators. No dam tour at the Hoover Dam because there wasn't power for the elevators. The only thing a dam's supposed to do is make power.
That's pretty funny.
Yeah.
And did you say you didn't make a sword?
Yeah.
Yeah, it was pretty
There, check it out. Not really, though.
You just see like YouTube how to make a sword?
Pretty much.
That's awesome.
He catches on fire later on. Sorry, guys. Quizzes aren't worth anything. Right here, watch this. I think it's this one. Watch his hand. He's making the point.
Yeah.
Oh, no, it's not that one. Must be this one. Yeah. Watch his hand.
Whoa.
You're on fire.
Good parenting, eh? I did put down the video to make sure he wasn't actually on fire.
You meant it as a compliment. You're on
Yeah.
fire, son.
Yeah.
Good job. All right, we'll catch up with you later.
And then, now check this one. This is grinding it out.
Hey, it's the real deal, right?
Oh yeah, it'll kill you.
He's just hanging up on his wall now?
No,
or-
he's got, it's a project for school.
Oh, cool. He doesn't take metal work at school?
They won't let him make a weapon in the middle school. They wouldn't let him make it here. That's why I had to do it on spring break. See ya. Yes, I am a good solid parent. I let my son make a sword. I've made better parenting decisions, but I've made worse, so. As long as he uses it responsibly. That's what every gun owner says. I should be allowed to have all the guns I want. I use them responsibly. So my son should be able to have all the broadswords he wants. It's less dangerous by a long shot. An automatic weapon will shoot 50 bullets a second. Line people up right, you can kill 50 people in 1 second. Right? Okay. Would anybody like to volunteer their answer for number 1? Michael. D as in, don't stop this man. He is on a roll. What about number 2? Number 2, C. Absolutely correct. Do I need to go over either of them? Does anybody need to see either one of them gone over? Going once. Okay. That 3 goes everywhere. So I get a cubed over this becomes 2a squared, and then it's cubed. So it's 8a to the 6th. Those a's all cancel. That goes down to 3. Can't have a 0 on the top. 1 over 8a3. This one is b to the 6th over 4 plus 3, 2b to the 7. 6 minus 7, right, is b to the negative 1. So the b has to stay down on the bottom, and I need a 1 on the top. Who's doing 3? 3. He waited patiently. A is correct. Well done. This is why. Tidy up the bottom first. K to the negative 2 over that is k to the negative 12. So negative 2 and k to the negative 12, which means I got 2k to the negative 14. The 2's cancel. Negative 2 minus 14 is negative 2 plus 14, which is k to the positive 12. And since it's positive, it comes up to the numerator. Who's doing 4? A, correct. 2p cubed, nothing changes. And on the bottom, I got p4 times p to the negative 4. What do you do with 4 and negative 4? Add them up, you get 0. So the bottom, there's nothing there. The only thing left is 2p cubed. And finally, who's doing 5? D. And y? X to the 4th over 8x to the 9th times x, which is x to the 4th over 8x to the 10th. 4 of them go away. 4 of them go away. 1, 8x6. D. Everything on that page is out of 5 because they're multiple choice. Turn the page over. I only got 6 minutes, so make them quick. What's this one? Everything on this page is worth 1 because it's the same tactics. Go. Michael, go. 4 root 6. 7. 3 root 5. 4 root 2. 24 root 5. Negative 56 root 3. 10 root 3. Now, tricky. Negative 49. Perfect. 13. Negative 20. Negative 40. U, v squared, root 2u. This is a very difficult lesson to teach in Australia because in Australia the word root has a very naughty meaning. Well, what do you think it means? Root in Australia is another word for sexual intercourse. So you don't want to go to Australia and say you root for a team. That's 64 times 2. What's the square root of 64? And what's 8 times 5? So give yourself a half a mark. And 14? 14? Negative 20. A squared root 2b. That's out of 14. Now, if you just got back, this was recorded. You can mark it yourself tonight, and I'll get everybody's marks tomorrow. Okay? It's out of 19 total. Tomorrow, I expect to see page 106, which is entitled page 227, done. The answers are on page 107. Check what? For the work? Yeah, just the answer there to check. Because they would be there in a textbook as well.